It has come to our attention that a certain Aussie YouTuber has been misleading his subscribers and others by purporting to show how to make a robot dog. We call him Sleepy, Low Life, Little, Lying, Do Nothing, Bushwhacker, Spot, Micro, Corgi, Dog, Maker, Man. At many times he has shown misleading information and demonstrated his ignorance. Finally, it can be revealed that his project was corrupted from the start by using a power supply that was adequate for testing but inadequate once the pooch hit the cooch. His actions in deceiving his viewers must be considered a witch hoax, and he should be punished big league for his fake views. We are Address Bus. We do not control Z. We do not reset.
Geez, now I'm in trouble with the guys at Address Bus, whoever they are. Oh. Anyhow, before I get to the embarrassing admission of a mistake I made right back at the start, just want to quickly show you why I love my 3D printer. My previous videos, I literally attached the camera using elastic bands to the handle of the tripod, which accounts for why some of them were a bit shaky and misframed, etc. So I thought that's not good enough. So I quickly measured up my phone, got on my printer, and printed a phone holder which clips onto the tripod using the standard spring clip at the bottom there. So now I can slip my phone into the holder and everything's going to be nicely framed and stable, hopefully. So now for the big confession. Right throughout this exercise I've been using external power supplies to power my models. I would use various ones. The latest one I was using is this guy, which is a variable power supply. You can switch to different voltages, which was handy at times. The embarrassing thing is that this has output 600 milliamps, which, as you may remember in my initial testing, Spot was hung up on a string, so the servos were free to move. There was no particular load on them. That power supply was fine for that situation. Unfortunately, as you also saw, as soon as I put Spot on the ground, everything went haywire. So I discovered, after installing the batteries in the new Spot design, the 18650s, everything worked fine with the batteries in there. When I switched back to the external power supply, it didn't work fine. So I came to the realization that the power, or the ampage on that power supply was inadequate to actually operate the servos under load. So that explains everything right back to the very start. So I'm embarrassed about that. And anyhow, live and learn. So with that admission out of the way, I thought I'd quickly go through some of the features of the redesign, which, you know, in hindsight turned out to be probably unnecessary, but still it's been a good exercise throughout the way, and I'm quite happy with the way, you know, the chassis has been redesigned to incorporate the battery holders. So the battery holders themselves, sorry if I can find one, are just cheap. You can order them online for, you know, a few dollars each. Just dig one out, sorry. They look like that, and they come, as I say, they're literally, I don't know, maybe a couple of dollars each. Now, I toyed with the idea of actually incorporating the battery holder in there, but thought that's you know, redundant. I don't need to have a battery holder inside a battery holder. So all I did was chop the bits out, the little springs and contacts, pulled those out, and incorporated those into the chassis, into Spot's chassis. So as you can see, that they're exactly the springs and contacts in there. Those two are just connected to each other, so that gives me the parallel connections between those two bays. The other side is where the power takeoff comes. So there's the red wire there is linking positive to positive, and then power takeoff goes underneath. Then there's also a black wire connecting the spring to the spring, with the power takeoff going through the switch at the front here and into the electronics underneath. Again, you'll notice the Mega sort of hanging off the top there. That was due to a couple of things. One was I cooked a Nano, which, as I've said in the previous video, I think was because I mishandled the power regulator. So I was running off the Mega. The other issue with the Nano is that the infrared remote library is not compatible with the Nano. So I sort of went into a waiting game where I was hoping someone would update the library for IR remote in time for me to press ahead with using the Nano as designed. In the meantime, don't you love it when these packages come? I ordered another Nano, which, as I say, I'm hoping someone will update the library in time for me to be able to use that. And also a Nano 33 IoT board, which incorporates Bluetooth, Wi-Fi, plus it's got 6-axis accelerometers and gyroscopes. So that sort of reduces the need for me to use an external board for those functions when we get up to that. So that's sort of the backstory. So this is the design. This chassis design is pretty well complete. The only thing I want to do is put notches into these top rails here to make it a bit easier to get the batteries in and out, because when you're putting the batteries in, it would just be nice to have just a little notch there to let that battery go in and out more easily. As to the electronics underneath, nothing's changed from the previous video. So we've got the power regulator, the PCA 9685, and that's all, as I say, as it was in the previous video. Space for the Nano to sit there. The Nano will then connect to the PCA 9685 using these connections here, which are currently feeding the Mega. So as far as the redesign goes, that's about it. There's my modified servo horns there with the taller boss to allow the bearing to sit in there on top of the servo. That's about where it's at. Now, as far as redesign and that goes, that's sort of it. I mean, most of that I've already covered in previous videos. But of course, the big question: does it work? So the next section of this video, I will answer that question, and spoiler, the answer is yes. Okay, so see you in the next section. Okay, so here we are. I was going to drone on and on about printing recommendations and bits to use and whatnot. Then I thought, let's not do that. Let's meet Spot Corky. Say hello, Spot. Good boy. So there you go. It's actually moving. Now I've programmed a few little positions into it at this stage. There's standing. Now if we go to sit from here, you sometimes go begs. Oops, sorry, that's crouch. Stand. Sit. Let's try stand again. These the infrared's still giving me trouble. It's something to do with the timing of the read. It's just very annoying. But anyhow, so there you go. There's Spot Corgi. I can say hello again, Spot. Good boy. And that's about all I have to show at this stage. I mean, I personally think it's come a long way. And that's his other trick. He can do beg as well sometimes if you go to stand. But that's where it's at this stage. he's moving. He's got enough power in the servos, and I'm quite pleased with where it is at this stage. These infrareds are annoying, but you'll get bored if I keep going over and over with the same movements. So I'll go back to what I originally said I was going to do, and just give some tips on printing. I will have this chassis model up onto Thingiverse by the time this video is ready. So I just thought I'd give some printing tips if people wanted to get started. I don't know whether anyone actually does, but I'm sure some people might be interested in having a go at it. Now, one of the main things is that with the redesigned chassis, this base plate, which is actually the battery holder, gives a great deal of strength, as you can see, because of the ribs and the thickness of the base plate. Gives a great deal of strength, which means these side panels and other bits, you can print those at lower print densities. I think I did these, I can't remember whether it's 50% or 70%, but you can actually cut those down quite a bit. Because this bit's quite short as well, you're not having a great deal of strain put onto those joints. Same goes for these and the end spaces. Since all the strength is coming from the base, these essentially just need to space these parts and hold them together. So again, you can print those at 50, 70%. They don't have to be super high density printing. The top and bottom covers, which print standing up like that, you have to do dense, otherwise they just don't print right. That one's PET G, which I quite like as a material. It seems to give a bit more strength. That's actually wood grain PLA, which sort of looks like a dog fur. They'll go on top and bottom, and then I can launch on the adventure of creating the head as well. As I said before, I've got this new IoT Nano, which has the accelerometers and Bluetooth and Wi-Fi built into it. So I'm hoping that I can actually use the Bluetooth for the commands rather than relying on this infrared, which has turned out to be pretty unreliable. But that's it, so I can't resist. We'll just do another say goodbye spot and say bye bye. He's a good boy, isn't he? Okay, that's where he's up to. I'm quite pleased with how it's all worked out. As I said in the last video, last section, sorry, I'm quite embarrassed about that mistake with the power supplies. Again, as you can see, the Mega on the top there is a bit messy. I've got to tidy up these wires as well and put on some wire guides for those to tidy them up. But other than that, I'm quite pleased with how it's turned out. So we'll see how it progresses from here. Okay, see ya.